Recording in progress. Welcome to our first discussion on materials. So for today, Project 5 becomes Project 6. Now, not all of Project 5 becomes Project 6. Let's specify that. All right, so the two environments, day, night, interior, exterior, become Project 6. Not the MyComp portion. You got enough to do with two scenes to add materials completely to everything in the scene. So this is going to be the scene, the day and night scenes that you did in Project 5. Remember, you should have one day, one night, one interior, one exterior, opposite time of day, opposite environment. And your lighting set the groundwork for adding materials. Now, materials are not textures. They are not maps. They are what makes an object look smooth, what makes it look rough, what makes it look shiny, what makes it look dull, what makes it look transparent, clear, glass, plastic, water, metal. Metal is a different property than plastic or concrete or wood or paper. So it all has to do with how your object appears in your reference. So there's another big thing that you're going to be doing today, and that is finding reference for everything in your scenes. So we'll get into that in a second. Just kind of give you a brief overview. So for today, we've got some downloads. I've got a Lecture 6 demo files. It's a very simple plane, sphere, and a helix so that we can demo how materials work in Arnold. Now, in Arnold, we are not using presets because, quite frankly, I mean, presets are okay, but if you can't alter the preset or understand what you're doing, you're not going to last very long out there in the field. You got to know what you're doing. You got to know how to alter it. So honestly, once you learn how to make materials, you're not going to want to use presets because you're going to go in a very methodical order to find out what gives that materials a look that we see. So we give you a couple reference images. One is the bread because we modeled this loaf of bread on the table. One looks like a big potato. We modeled that loosely off of the reference we give you. We've also got a brushed metal thermal container for the interior on the desk. So we give you those because those objects were specifically modeled from those references. Everything else you are responsible for finding on your own. So anybody have any questions, feel free, just, unmute yourself, type it in chat, let me know. All right, so tomorrow I'm out of the office taking some PTO days because I have to use them up at Full Sail before I lose them. So I'll be out Tuesday and Thursday, but you can still get help on Discord. Frank or Ari will be doing the Zoom Open Lab on Thursdays. So Thursday, it is for online and campus students. 1 to 5 p.m. optional, as always. Okay, so a couple things about Okay, so no preset materials. You have to know what you're doing. You have to understand. And when we ask you, why did you do that? You have to give us, oh, because of this. And how did you do it? Oh, I did it this way. Not just like, oh, because it was in the material. No, that doesn't fly. Okay. So you guys will need to find reference. For all objects in your scenes that are visible to the camera in both shots. So that's in the long shot and the close-up. All right. So reference images for today, we are dealing with reflectivity only. We are not dealing with glass. We're not dealing with transparency. Today is all about reflectivity and whether it is metal or something else other than metal, because there are two paths to take when you're making a material. If it's metal, your path is predefined by a couple of settings in Arnold. If it's something else, then it's a different path. It's kind of like coming to the fork in the road. Where do you go? All right, so your reference needs to tell you three things. Good reference will be able to help you make materials. One, how reflective is your surface? Surface, object. Number two, how rough is it? And number three, what color? Those are the three main questions that reference material should tell you. So today we are dealing with reflection, specularity, roughness. Color is in there, but quite honestly, color is the last thing you want to do. Why? Because we are, as humans, distracted by things that move and shiny objects and colorful objects. So we're taking the color out until the very end so that we can focus on how reflective is the surface and how rough is the surface. Everything else will fall into place once you've established the first two. It's like the principles of light. You always go light direction first, light intensity, light color, shadow quality. Okay, when you're making a material, how reflective is it? How rough is it? What color is it? If it's metal, that's a little bit different. It's still going to be, what kind of metal is it? Which is, how reflective is it? And also, how rough is it? That is pretty universal for any object. And then, what color is your metal? And you say, what, metal? Yes, metal can either be white metal or red metal. We'll get into that in a little bit. Now, common misperception is that you change the color of your reflections based on what you see. That is a misunderstanding. The color from your environment will come from the objects in your scene and your dome light and your image. We do not change the color of your reflection unless it is metal and unless it's red metal specifically. Everything else has a white reflection, which is neutral and will reflect the environment accurately. Does that make sense? Questions? Okay, Michael's good. Jackson, questions? Make sense? Okay. Jackson's good here. He's the lone Full Sail soldier. Okay, good. All right. So this is kind of just a brief overview. We'll go over in more detail, all of this stuff, but, your reference, what it needs to tell you, that's pretty much standard for everything you're going to do. Sounds very simple, but honestly, it really is once you understand what you need to do, why you need to do it, and then how do you do it? Okay. So in addition to Project 6, you will also have a topical discussion, which is about materials, and you will also get a chance to do a research discussion. The research discussion, so Baltran asks, what red metal reflects different? We'll get into that, Bal, when we get into talking about metal. So hang on to that question. And if I don't answer it, make sure you bring it up again. But I'm pretty sure we're going to address it. So anyway, back to the research discussion. This does not have to be SAL related, but it does have to be industry related, meaning 3D arts. Whether you're in computer animation or game art, doesn't matter. They are both so interrelated now that it's really, there really shouldn't be a division. Theoretically in game art, you're going to work more in real time, although that has changed drastically over the past 3 years. We started doing, before the pandemic, we started messing around with real time. Anybody remembers Mandalorian was done way back in they started it in 2018. And by the time it was released in 2019, okay, the pandemic was just starting and everybody kind of jumped on board because they realized virtual production was a really good, safe way to do production work without traveling. And you got to be able to do a lot of your lighting, a lot of your filming, and be able to have your set actually give you the light from the environment. You didn't have to do a lot of green screen, a lot of blue screen, which is really annoying because then you got to do color corrections. This gave you the look and feel that you wanted right up front. Having said that, back to the research discussion, we give you some options that you can do here. So, give you a list of databases where you can go look for sources that interest you. Now, this could be anything. It could be game art, computer animation, it could be texturing, it could be rendering, it could be cinematography, it could be rigging, it could be animation. It doesn't have to be related to shading and lighting. So you can use the EBSCO database, which is available from our library research database. If you go into Full Sail 1, go to library, you can get there. Now, there's a bunch of databases in EBSCO. Use either EBSCO Complete or EBSCO Host or whatever you want to use. Search for your article. Gave you some topics at the bottom, gave you a couple ideas just now. If you don't find anything there and you want to do an online journal, there are two that we have approved here for you. One is Game Sutra and the other is Game Studies. Now, If you don't find anything you like here and you find another source, you need to get it approved. Send me a link. I will go look at it. The idea is we don't want you just going to a blog, going somewhere where, you're just looking at people rant and rave and troll other people. And, we want some credibility. We want somebody who's been in the industry, somebody who either reviews games or computer animation, 3D art professionally. Or, maybe it's a research facility, could be a university, could be a simulation company, doing medical, doing military, doing accident reconstruction. It doesn't really matter what it is. If you find another source, please send it to me so I can take a look at it. Send it to your instructor. If you're on campus, that would be me. If you're online, that would be Tony Bagsby, who's our associate course director, and also me. Depends on what section you're in online. So the idea is you find a topic that you want to do, you research articles, you find an article you want to review. No, it's not a review. You find an article you want to discuss. And the discussion is not going to be a recap of what the article is. You need to be able to thread the you component into your discussion, which means you need to be able to say, why was it important to you? Why was it motivating to you? Why was it relevant to you? Any other comments that apply to your article that you can relate to. I started to read it because I thought it was this, but it wasn't, and just whether you like it or not, it doesn't matter. Just tell us how you related to it, whether it was good, bad, indifferent, whether you thought you got the information, how you may have been impacted by the topic you're talking about from an early age or not, something you just found out about. But the idea is you are giving the reader a glimpse into you. So, very particular format for this discussion. It's a discussion, but it is more formalized. We need a citation. You guys should know what citations are. You guys have done it before. We use the APA, the American Psychological Association citation format. If you're not familiar with it, look it up. All right, this goes at the top of your discussion. It's usually, journal, page number, who wrote the article, what the article's called, but it's in a very specific format. We need a link to the article. If you're in EBSCO, we need what's called a permalink. You can't just copy the URL because when you quit out of EBSCO or the online database, that link goes away. A permalink means anybody with the link can look at it anytime. If you're doing one of the online journals, Game Sutra, Game Studies, you can copy the URL because obviously you are going directly to the source. Read the article and then discuss it using the criteria below. Again, why you read it, why was it important, why was it motivating, why was it relevant, how did it impact you? So that will be due, and I'm talking about this now so that you guys can get a jump on it, because Project 6, fortunately, is 2 lectures and 2 labs. But don't think, oh man, good, off the hook for today. Nope, it's going to take you every bit of time. Please do not underestimate how much work this is. All right, any questions so far? 6.3, The activities got the instructions there. I just like to kind of go over it, maybe clarify on a couple of points that usually get overlooked. All right, so having said that, if you go to EBSCO and you find your article and click on it, this is pretty much what it'll look like in the EBSCO kind of like landing page for that article, the home page for that article. You're going to have either a PDF link or an HTML full article link. There's a citation button. Click on that. That'll give you the citation for the article, either in, any format. We use APA. And then there's a permalink to the article. The permalink will get anybody there, whether they are logged in or not. And it is completely independent of your sign-on session. Now, like I said, if you're using Game Sutra or Game Studies, you can copy the URL, but if you're using research from EBSCO, you can't. All right, so that's kind of a quick overview of what that looks like. If you do not test your link and just send me, you copied it out of the URL from EBSCO, I will get an error message like this. Every couple of months, EBSCO changes their error messages. This is pretty much the latest one that they're pumping out there. This means it was just copied. You can see down here, one thing that gives me a clue right away in the naming, right here, there's something called Session Manager, which tells me that link is only good for the time you are signed on to EBSCO, you being the original user and researcher. When you copy that and you end the session, that link goes away. So please make sure you test your articles, or I should say your links. All right, so also be aware that you must use an article that is a full article and not an abstract. Abstracts are basically very brief overviews of usually fairly long, formal researched articles. So you want to make sure you get a full article. If I get an abstract and I don't have a link to a full article anywhere, there's going to be points deducted because I need to see the entire article. So here we've got citation is correct, the link is correct, and the discussion underneath is correct. All right, so kind of a brief overview of the 6.3 research discussion. Any questions so far? Okay, Michael's good, Javier is good. Yangi's good, awesome. All right, let me get a quick screenshot here so I can get attendance for everybody. Now that we had a couple people come in. Okay, so let's plow on and actually talk about materials. So we briefly talked about this type of reflection in lecture 2. Does anybody remember what type of reflection is this technically called? Ooh, awkward silence. Nobody's awake, nobody's had caffeine, or everybody is thumbing through their notes or going, what?
I'm guessing direct.
Direct what?
Direct light.
Okay, but we're asking what kind of reflection is the surface giving us? Because it doesn't matter the kind of light that hits it. The surface is going to alter how the light bounces off of it.
Let's see. It's It's kind of matte.
Okay, that's a good start. Take a look at the little diagram on the right. That might help.
Okay. Uh,
Give you one clue right here.
Scatter reflection.
Scatter simply means diffused.
Oh, okay.
And this is technically a diffuse reflection. When
Okay.
it looks matte, what it's doing is the surface has microscopic irregularities. And with a matte or diffuse surface, the light is scattered equally across the entire surface. All those little nooks and crannies tend to take those direct light rays that come in and scatter them so that when they bounce off the surface, they are all kind of mixed up. They're kind of jumbled and well shaken, right? Or diffused. So diffused surface, remember with a diffused surface, okay, we see basically no environment reflections. And we see no direct light highlight, sometimes called a speck highlight. So that is the mark of a diffused surface. At any angle, doesn't matter whether you get up to it really close, look at it straight on, look at it from a 90-degree angle, or a 60-degree angle, or a 35-degree angle on the side. Okay, it looks more or less uniform at any angle. Now, compare that with what we would call a reflective surface. So a reflective surface is smoother. In this example, we've got sort of like a mirror surface. You can see it is pretty clean, pretty straight, pretty void of, I would say, the noticeable imperfections that you see in a diffuse surface. Now, it's a common misunderstanding that a mirror is completely flat. If you zoom into it with a powerful enough camera or microscope, you will be able to see the imperfections in the surface, but they are so small that generally by the time light bounces off of it, it's really not that much of an issue. The light bouncing off of it appears to be organized. So a reflective surface, you'll be able to see your surrounding environment. And that is because our angle of incidence, the incoming light ray, hits the surface and it bounces back at more or less the opposite angle. That's the angle of reflection. Now, in CG, we measure everything based off of the camera normal. Or actually, not camera normal, because cameras have a normal, but surfaces have a normal also. So the camera normal simply is where the camera is pointing and facing. The surface normal, or if you guys are familiar with from modeling, the poly normal, right? Every polygon has a face normal. That gives us in CG the ability to identify that surface in 3D space and also which direction it is pointing. And based on the angle of that normal to the angle of the camera, how that reflection should look. So everything's all about the angle of the camera to the angle of the surface normal. And also now we're introducing light. So light is hitting the surface. It is bouncing off of the surface because it is a reflective surface and not an absorbing surface. So it's reflecting off the surface, since it's smooth, at a predictable angle of reflection. Now, one other property that is exhibited in a reflective surface is what we call a specular highlight. And this is basically a direct light source highlight. So let's see. Oh, somebody left a pair of sunglasses. So sunglasses. If I move my light in here, my light's not on. There we go. So sunglasses, you can see where I put the light. That little round light shape, that is a specular highlight. What's happening is the light is bouncing off. The light hits the surface, it bounces off the surface and finds its way into the camera or your eye. All right, does that make sense? Okay. Michael's good. Anybody else? All right, so our typical average reflected surface is a combination of actually three components. And an average reflective surface is called an isotropic reflection. So it is a combination of a base reflection, which is almost just pure color, actual environment reflections, depending on how rough the surface is. Those environment reflections will be clear or they could be blurry. We've got a specular highlight, which is a direct light highlight. The result, all three of those, remember, lighting's additive. A lot of things we do in CG are additive. So you add in the actual reflections to the base, and then the specular on top of that, and you come up with your final surface. So, same kind of deal. If I take my tablet base here, so you can kind of see, kind of stretches a little bit. But if I put it inside here, it's a little more smooth. Trying to find a good place to show where that is. It's kind of hard. I know what I'll do. I've got a mouse in my bag that I usually use for just such an occasion. Let me get my mouse out. All right, so mouse time. So this is an average ordinary mouse. It's got three different types of surface on it. Okay, on the back, I've got a smoother, kind of very hard plastic surface. On the top, I've got a slightly rougher surface. So I'm shining my flashlight from my phone onto that surface. And you should be able to see. And let me switch. Let me make this a little bigger. All right, so there we are. You can see that my flashlight right here. Shows up as a nice round little highlight there. It's pretty nice. It's pretty tight. You can see some environment reflections if I come in close enough. There it is. And you can see if I turn that in any direction, that round highlight stays pretty much uniform, no matter where I move it. All right, so I changed the position of my mouse. Now that same highlight is really blurred out. So this is a rougher surface. I go to the side and it's got like a, kind of rubber grip on the side. You can see that it is blurred even more. So the surface is doing a lot to my reflection. Now, what does that mean for us? Well, that means that based on the type of surface we have, our reflection will change. Kind of pull this up again. There we go. So that's called an isotropic reflection because no matter how you turn that surface, the reflection, especially that direct highlight on the light, stays the same. All right, so one other thing that you're going to notice is when you've got a surface that has intentional roughness. So I've got intentional roughness here on the side of my pen base for my tablet. And you can see when I put the light on it, it kind of stretches horizontally. And when I turn it, it now stretches, well, it stretches vertically, sorry. It stretches vertically this way. When I turn it 90 degrees, it stretches horizontally. So that is typical of what is called an anisotropic reflection. We'll get into that. Anisotropic, think of kind of as brushed metal. All right, now, while we're talking about color, about a year ago, Unreal had a virtual festival on, so we all went. It was pretty cool because the one thing they talked about was people who first get into gaming and CG in general tend to make white objects pure white and black objects pure black. And they said nothing looks more CG than pure white or pure black. So they went and they did a bunch of examples. They were showing a bunch of photos they took. And then they had this one slide that kind of encapsulated everything. So basically, they had an example of charcoal, which is actually a fairly dark material. And they said when they measure charcoal in Photoshop, it comes up to be around 0.02. Now, if you remember, black is equal to 0, and white is equal to 1. So you want to stay away from pure blacks and pure whites. Because charcoal, they kind of measured at 0.02. Snow, and this was very bright, kind of, sunny day. Snow was about 0.8. They said between 0.8, 0.85, but it didn't hit 0.9. And they said a lot of things that look artificial are pure white or pure black. So make sure that when we talk about an object like this, I will ask people, what color is it? And they will go black. And I will go, no, it is dark gray. Nothing is pure black except a black hole or even Vanta black. which is a special paint that kind of absorbs and scatters light so much that it does not look like light gets out at all.
Is there anything that's pure white?
Honestly, not really. Because it can always be measured close to pure white. Well, let me put it this way. In JPEG photos, there are pure blacks and pure whites because of the compression process. But if you were to measure that same image using a raw image format, meaning it's not compressed, it hasn't been touched, you will probably find that it does not reach 1 or it does not reach black. 1 being white, black being 0. So in the real world, our eyes probably perceive things as being very white, and pure white only because it probably goes out of the spectrum of our ability to see it any brighter or any darker. So honestly, things can keep going, but remember, we've got this electromagnetic spectrum of light that our visible eyes can see. And if it goes above that bandwidth, we can't see it. So we would just call it white. If it goes below the bandwidth, we can't see it. So we would call it black. Does that make sense? All right. Questions? All right, Michael's good. So just remember, no pure blacks, no pure whites. It's going to be bright, but it shouldn't be white so it looks realistic. So talked a little bit about my mouse. Same one we got here. So this was back at my desk. Full sail here. And you can see that I sat it on the desk. I've got it sitting actually on top of my base for my pen. Took a picture of it. I've got an overhead rectangular light. And you can see that it is a highly reflective surface. This would be considered a low roughness surface, very reflective, hard, smooth, sometimes called a high glossy surface. You'll have detailed, sharp-looking reflections, and you'll have a visible light source that is not kind of scattered or softened or bloomed. It doesn't kind of blur out. Unless, of course, it is too bright for the camera to pick up. You'll notice behind it, I've got a dark cloth hat. That would be considered a diffuse surface because it's got all those little fibers on the hat that diffuse the light and make it very matte looking. So the hat's under the same level of light as the mouse. So it's just there to contrast so you can get an idea of the reflectivity of the back of this mouse. Now, like I said, and I tried to show earlier, this is a little more controlled environment because they're pictures. Okay, same environment, just put the mouse on top of the base and was able to take a picture of the area where the buttons are, right here. You can see that the light is softened a whole lot. Still the same light, still the same shape, more or less in the same position. Camera's a little bit different. I was more overhead trying to get a downward shot at 0 degree. But you can see I've still got some environment here, but this is pretty blurred out. So this would be a medium to high roughness reflective surface. It's got blurry reflections, would also be considered a low glossy surface. You'll hear glossiness and roughness used sometimes interchangeably. A lot of specular or reflective models use either spec gloss or metallic roughness. Whereas we kind of use a hybrid. We use kind of specular roughness, which is closer to the PBR workflow, which is physically based rendering materials that most game engines use. And quite frankly, most rendering engines also use that, although the naming might be a little different. Now we get to the side of the mouse. This is that rubbery surface. This is a higher level of roughness. So this would be a very high roughness surface, very blurry reflections, and a very low amount of surface glossiness. Very soft highlights, almost to the point of being diffused, which you can see compared to the hat, we're not there yet. All right. I lose anybody so far? Still good? Jackson, you still good? Okay, Jackson's good.
Still good for me here.
Okay, thank you, Will. Tyra's good. Ion, how about you? Bao, Blaine, Derek, Katerina, Janelle. Okay, Michael's still tracking. That's good. Yangi, Javier, Nicholas, Lauren. Anybody got questions? Okay, let's continue on. Now, when we start talking about reflectivity and transparency, what we're doing is we're really talking about what's called conservation of energy. You can only have 100% of the energy in a material or in an object at any one time. That goes for, the physical laws of matter and our kind of real world, if you want to put it that way. Well, we try to simulate that in CG. So we make our materials behave the same way. Up until today, except for the portrait in Project 3, everything we've done has had just base material with the base color, 50% gray. Right? Base weight went all the way up. Our color was 0.5, and we always turned the specular weight down. Now, in the real world, once we start adding specular or reflectivity, okay, it's going to steal from the base. So, whereas Project 2, Project 5, we had 100% diffuse or base. Now, once we start adding material reflectivity, we're going to be stealing from that. So the base weight's going to be lowered most of the time automatically. So when we add specular or reflection, the energy is taken from diffuse. On Monday, when we talk about refraction, we're going to add in transparency and refraction. That is going to steal pretty much all the energy from the diffuse, because most glass, most plastic, most completely transparent objects, or even clear liquids like water, isopropyl alcohol, okay, they all will take on some level of reflectivity, but not much. The bulk of the energy is going to be transparency. All right, does that make sense? So it's all about balancing the level of energy, 100% at any one time. All right, now we get into two different types of materials and two different types of workflows. We've got what are called dielectric materials. And basically, a dielectric material is anything but glass. Or sorry, anything but metal. Because we're not talking about glass yet. All right, so dielectric material, Anything but metal. Down here, conductor materials. These are metal materials only. So this is anything. Well, I don't want to say anything because it's a lot more limited than above. I was going to say anything but dielectric materials. But this is basically everything that is metal. Workflow is a little bit different. The things that defines it here, this little slider right here. That metalness slider makes the material behave in a metallic fashion. It uses what is called Fresnel reflections. Fresnel reflections are how does reflectivity and your viewing angle make things appear differently. All right, so dielectric materials, specular Fresnel response, or how it reflects, will be controlled by the base color. So the base color, that is basically what is the color of your object. Specular weight, specular color. Specular color is always going to be white. We do not change specular color. Now, down here in the conductor or metal, this is always white. Unless you have red metal. And that's the only time we ever change specular color. So we'll get into that in a second. So let's take a look at what we consider to be dielectric materials. And this is just a very limited list. Okay, dielectric materials, anything like paper, porcelain, even glass is considered dielectric because you can see through it. It acts like an insulator. Plastics, air, rubber, wood, some are better insulators or dielectric materials than others. On the right, we've got conductors or metallic objects: steel, copper, aluminum, iron, gold, silver, brass, bronze, titanium, you name it. If it's metal, it belongs in this column. Now, metal materials, we break down into two different kinds. So everything I'm giving you here is going to be important because this all relates to everything you're going to be doing in Project 6. All right, so let's break it down into the two different types of materials that we have. So we've got steel. Steel is considered to be a white metal. Why? When it reflects back, it's mostly what color? Some people say gray, some people say silver. Okay, if it's gray, if it's silver, that's a white metal. Got aluminum, same kind of thing. Got iron, same thing. You got silver, same thing. On the other end, we've got things like copper. Copper reflects back as kind of an orangey reddish color. Gold, kind of yellowy, kind of, you know, if you had to mix colors together, and remember we mix color with light, it'd probably be reddish and greenish, and that gives you kind of that yellowy orange color. We got brass, we got bronze. These are all considered red metals. Why? Because that is primarily the color that is reflected back to us. Us also being the camera. Now, why do we see it that way? Well, it really goes back to why we see red in this sphere. We see red in that sphere because those are the wavelengths or colors that reflect back, and that's what we see. The other colors are absorbed. So if you remember, to make white in light, you need to have red, green, and blue equal in all parts. So steel, aluminum, silver, titanium, stainless steel, iron, they are all considered white because they reflect back the wavelengths of light equally. Now, red, we see, you know, the oranges, the yellows, the reds. We see that because those are the primary colors that are being reflected back. The other colors are absorbed. Now, if anybody's interested in taking a look at this phenomenon, I've got a link inside Project 6 here. It's called Why Copper is Reddish in Color. So it's a pretty good paper. It pretty much will go through and tell you exactly what I did, but in a little more scientific terms. You can get through the first page. After that, it gets into a little more math that's way over my head, but you get the idea. Just know that it's red because those are the wavelengths that reflect back. The others are white because it is reflecting all the different wavelengths equally. All right, Val, did that answer your question? Because you were the one who asked about red metals when we first started talking about it. Okay, good. So like I said, that PDF is there. It's a good explanation, but this is why we only change the specular color when it has to do with red metal. Everything else should reflect light equally. And if there's any color in the reflections, that is due to the environment. So if you take a look at my mouse, you can see I got a little bit of blue from my screen, a little bit of red from my phone. On the right, okay, those colors are coming from the reflected light, not from the color that we artificially change. That artificial change would be basically in the specular color. So specular color always remains white unless you're using red metal. All right, so base color, this is the color at what we call a facing angle of a 0 degree. So Fresnel reflections, let's talk about that briefly. It is French. Do not say Fresnel or you will probably be laughed out of the meeting you're in. Fresnel reflections. Okay, it is how we see reflectivity or objects at different viewing angles. So, give you an example. Probably everybody has been to a lake, a stream, the ocean, hopefully at one point, or a pool even. All right, so you walk down to the shore of a lake or the shore of the ocean, right? You stick your feet in, you look straight down. You can see, usually if the water's not too bad, you can usually see through the water and see your feet. Now, imagine you are looking down. Looking down is a 0-degree reflection. We look at something straight on. Now, imagine you pick your head up and you start looking toward the horizon. When you get close to the horizon, which is usually a 90-degree angle, the water becomes less and less transparent as you pick your head up, and it starts to become more reflective. Okay, that phenomenon of having it change from being clear and see-through to being reflective is part of this Fresnel reflection. So when we get to 90 degrees, we're looking at what's called a glancing angle. Sometimes called a grazing angle. All right. We always see more reflectivity at a 90-degree angle than we usually do at a 0-degree. So another example would be you're driving down a long stretch of highway. Dark asphalt, or it could even be concrete. So you're in front of the car, everything looks pretty cool. You look in front, maybe a couple hundred feet out, everything's looking good. And if you can see that road go off into the distance, how kind of our perspective changes as it gets further away, the road gets closer together. Okay, off toward the horizon, it might start to look wet. Now, this is usually occurring on a sunny day. And what's usually happening is in front of the car, and even a couple hundred feet, you're seeing basically a 0-degree reflection. Not really, but you're looking at, I don't know, maybe 30 degrees. 30 degrees. As you start to pick your head up toward the horizon, you get closer to 90. The road becomes more reflective. And consequently, it usually looks wet down there. And what you're seeing is a high degree of reflectivity. Like I said, most objects exhibit a high degree of reflectivity at 90 degrees, and usually not as much at 0. If you see a lot of reflectivity at 0 and at 90, you're probably looking at something like a mirror or polished chrome, something that's very hard, very smooth throughout the entire viewing angle. So, base color, that's going to be the color when we look at it 90 degrees. Specular weight, that's the brightness of the specular highlight, meaning this is your amount of reflectivity. Specular color, we always leave it at white except for red metals. So when you're making dielectric materials, you don't even think about specular color. Specular color is always white. Does that make sense? Questions? Please? Now? Want to make sure everybody understands this because this is kind of key to getting the idea of what's going on with materials. And this is not just Arnold or Maya. This is pretty much anywhere you go, any application you work. Now, granted, there are different workflows to achieve the same results, but in the end, this is basically what you are doing. Now, in gaming, a lot of times, we may bake some of our reflections into the specular color to save render time. But honestly, the days of the RTX 20 series graphics card have pretty much changed that. And even Radeon does ray tracing graphics cards. So your reflections are always going to be part of your environment. Whereas, for metal, it's going to tint the reflection a little bit if it's red metal. Copper, all the reflections in copper or gold or brass or bronze always have that reddish, orange, yellowish tint to it. All right, so base color, that's the color, 0 degree incidence or facing, looking right at the camera. Now, we have diffuse roughness, but we generally don't use diffuse roughness because this makes your material look like it is powder coated. Most of our roughness is going to come from specular. We'll talk a little bit about that also when we get to it. All right. Now, we get into conductors, conductor materials. This, we are talking about metal. So first thing, when you make metal, you turn metalness all the way up. And notice it kind of kills diffuse roughness. And it kind of kills a little slider down here called IOR, index of refraction. Because metalness forces the material to behave like metal with what's called a complex Fresnel reflection. Now, in metal, most of the time, you know how in a normal Fresnel reflection, everything is much more reflective at 90 degrees. In metal, it's not quite as reflective at 90 degrees. And that's what makes metal behave a little bit differently. All right, so the base color for metal, and we're talking about the base color up here, okay, should be gray or white for all metals except red. Speculars, the same thing, specular color. Should be, most of the time, I'm not even going to say gray, most of the time it's white. Because 90 degrees, we have a lot more reflectivity. So metal base color should be gray or white. And I'm going to show you how we decide how gray it is or how white it is. Specular weight is going to control the amount of edge reflectivity. Usually we start with that at 1. We can lower it if needed. The specular color, if it's red metal, this is where you're going to plug in your color. If it's white metal, you'll leave it at white. Now, I've got a checklist for you guys on how to make metal, because it is a little more involved than just going in and, dialing the amount of reflectivity in the specular weight and adjusting the roughness in the specular roughness, and then, color if there is any. So it's a little more complicated, and there are a few steps you need to do in the right order. All right, so roughness we deal with under specular, whether it's metal or whether it is dielectric. Okay, like I said, diffuse roughness is a completely different animal. I will address that when we get into the demo part and how it looks. I would say 95% of your roughness is going to come from specular. Now, the default is 0.2, which is quite a moderate amount of roughness. Most rendering engines start off with a good deal of roughness. RenderMan did it, V-Ray does it, Arnold does it. How clear or soft, soft being blurry, are your reflections? And that is basically your roughness. All right, questions? Good point to just pause for a second. See if anybody's got any questions. Okay, Michael's still good. It's good to hear. Okay, Blaine's good. Tyra's good. Michael's good. Thank you. Val taking some notes. Okay, good. All right, so while we're talking about metal, let's also talk about anisotropy. Now, some people have a lot of trouble with this word, but iso, that is the type of reflection we're dealing with, isotropic, meaning no matter how you rotate the object, the highlight is always going to remain round, and you're not going to see your reflections distorted. When we talk about anisotropy, that is basically creating brushed metal. And that's usually what we use anisotropic for, brushed metal. And that's when we have something that has intentional roughness and it stretches the highlight perpendicular or 90 degrees from the reflection. So let me pull up the reference we give you for that metal thermos right here. And let me zoom in. Let's go to actual size. Is that actual size already? All right, well, let's zoom in more. All right, so hopefully you can see this, but it's got little bits of brush stroke from a wire brush all along the surface. Full sails covered with brushed metal everywhere. Like here in the room, our kick plates, our door handles, the door bars. You go into the bathroom, the towel dispensers are brushed metal. The sinks are usually have brushed metal faucets on them. Okay, it has intentional roughness, and that's usually horizontal brush strokes. You know, they usually have some kind of wire brush that polishes it and puts that intentional roughness on there. All right, so what does that do to our highlight? Well, our highlight, let's go back here. So our highlight stretches vertically. So it's always 90 degrees or perpendicular to the roughness. So again, kind of got my little base here from my pen. Put a little light on it. You can see it kind of stretches. And it's plastic, but it's got intentional roughness. So if I turn it sideways, there we go. I turn it sideways, it stretches horizontally now. Why? Because my roughness is now vertical. This is one of the main properties of an anisotropic material. So again, it's actually quite simple to do in CG once you know all the dark secrets. So you basically make your metal material, find your settings for it. We're going to go over that in a little bit. Find your settings for it, which is going to be some shade of gray or white in the base color. Metalness goes all the way up. Usually keep your weight at 1. Your color, since it's going to be white metal, because it's stainless steel is a white metal. So the specular color stays there. We give it some roughness, and then we have to add in what's called anisotropy, which is right underneath at the bottom of specular. Once you turn that on, it will automatically create an anisotropic effect. And the only thing left for you to do is to rotate how you want that highlight to be stretched. Now, when you rotate, you would think, oh, cool, it's in degrees. No, it's not. It's 0 to 1. Why they did that, I have no idea. Why would you put the word rotation in and give everybody a 0 to 1 value? That's just cruel. I'm sorry. So anyway, so rotation is always at 0. Okay. If you want 90 degrees, 90 degrees would equal 2.25. If you want 180 degrees, that would equal 0.5. If you want 360, that would be 1. Most of the time, you're going to be rotating at 90 degrees. So quite honestly, that's exactly what I did here. I've got 3. I just duplicated that thermal container 2 times. The one in the middle is the base. When you make metal, your anisotropy is going to be 0, your rotation is going to be 0. So I increase the amount of anisotropy, and usually you go from 0 to 1. Honestly, I never go to 1 because 1 tends to make, when you go to denoise it, it tends to kind of look a little strange. I find if I keep it down under 1 at 0.95, I get the best results. But you turn up the anisotropy, and you can see that my highlights are stretching horizontally. That's because the rotation is at 0. As soon as I rotate it 0.25 or 90 degrees, now my highlight is stretching vertically. So honestly, to make most brushed metal, turn anisotropy up, rotate it 90 degrees or 0.25. If you've got the rest of your metal settings done, it looks good. So brushed metal, mischief managed. All right, we give you some resources. One is the standard surface Arnold for Maya user guide. It's actually a really good reference. So if you click on it, it'll take you to the Arnold. There we go. The Arnold standard surface user's guide. And quite honestly, they go through every single setting in each of the attributes. So this is what the base color does, or the base weight, the base color, surface roughness. You can see at 0, it's usually diffuse. You turn it up and it looks more powdery. Metalness, this is how we make metal. And there are some good resources here for making metal, but I'm going to show you another way because we're going to basically use what's called a refractive index right here. And this is built like a mythical place you guys may have heard about. Probably none of you have ever been to, called a library, a physical building where you go in and they have physical books and they have the bookshelves. And on the bookshelves, they have categories, and under categories, they have authors, and you just keep drilling down till you find the book you want. So most of the time, we're going to spend our time in the main simple inorganic materials. And by default, when you come to this website, you're going to find that you've got the book of silver. Kind of sounds great. I'm in the book of silver. So silver, and you can see if you scroll down, they've got all kinds of different metals and minerals, and they even get into gases too. Now, you might say to yourself, well, cool, if they have this and I can use this information, can I use it for plastic? Well, you sort of could, except that there are like 100,000 different kinds of plastics. Each kind of plastic or polymer has their own special set of, basically, it's its own recipe. There are tons of them. But here for silver, we have what's called the refractive index and extinction coefficient. This is basically how bright they are when you look at different directions. Arnold doesn't use this terminology. For Arnold, we scroll down and we use what is called reflectance calculator. So you'll see by default, example for silver, which is what we're looking at. Silver has a 0-degree reflectance of 0.995. What does that mean for us? Well, remember how I said here's your color. Well, actually here, base color. So if we're trying to make silver, our base color, which is 0-degree, is going to be 0.995. It's not going to be pure white. Now, if you want to know what is the reflectance of silver at 90 degrees, well, here in the reflectance calculator, you just type in 9 and hit enter. Notice it changes to 1, which means at 90 degrees, or your specular color, it's going to be white. So silver is going to be really, really bright for the base, 0.995, and super bright for the specular color, which is 90-degree viewing angle. That's going to be white. Turn metalness all the way up, and basically you've got silver. Now, if you want to do something like, let's go down and do another metal. Let's go to chromium. There we go, chromium. So come down here. Here's our reflectance. Let's go 0-degree. You can see that chromium, or chrome, is a lot less white when you look at it. So it's 0.648. So that's what you plug into your base color. Right? 90 degrees, just type in 90. You can see most metal is really bright or white at 90 degrees, which is our specular color. And then you adjust metalness, turn it up, and basically you will get chrome. So very useful guide. We're actually going to do some examples when we come back from break on it. Now, once we get into reflectivity, we need to worry about specular in our render settings. So whereas before we were just doing camera AA, diffuse, usually set your camera AA to 4, maybe diffuse at 6 or even 8. Okay, you got a good render. But now noise is going to happen in the reflections, separate from indirect light, which is what diffuse is. So when you render, if you notice noise in your reflections, you're going to have to crank up your specular. So again, 4 is going to be medium, 4, 6 is going to be medium high, 8 is going to be high. Just watch, when you turn this up, you are going to increase the render time. Don't forget, camera AA multiplies everything. It's the main multiplier. So I would start with it at 4, maybe 6, maybe if you have to, you go to 8. But don't immediately throw it on high quality. Because remember, your entire scene now is going to have reflectivity in it in some way. All right, does that make sense? Val says library. Nope, library. Never heard of a library. Okay. We have to look it up. You'll be entertained at the strange things humans have done in the past. All right, so this is a good time to take a break. Give me a chance to render out the first part of lecture. When we come back, have the Lecture 6 demo files downloaded. We can do a little follow along together. We're basically going to practice making some material properties. We're going to talk about look development. We've got a look development guide. We're going to talk about the project 6 specifications. And we'll wrap it up with some metal demo, and we'll hopefully get you guys on the right track for lab. Now, in lab today, Frank is going to do a presentation on look development reference, which is really important. I'm going to give you a brief overview. Frank's going to go into more detail. So let's see. Let's come back at 8:53. Let's be oddly specific. So I'll see you guys back here in about 20 minutes. Have a good break.